Good afternoon. Good afternoon, class. You're not supposed to say. I'm kind of the assistant principal, right? I take care of discipline. But this really is my very great pleasure to introduce my friend and my colleague and really a hero to I think everybody, Dr. Jim Hansen. And I gave a talk at I think it was the last week. He was still a NASA employee at the Goddard Institute for Space Studies in Columbia. It was the weekend of St. Patrick's Day, and it was snowing in New York. So we have a little better weather for you here today. But during that talk, you called me a Fulani, which is a great compliment, by the way. Look it up. But the chief of the whole tribe of Fulanis is Jim Hansen, and he has revolutionized our understanding of what's happening to our climate. I won't go through the details of his bio, but he is, without a doubt, the most recognizable climate scientist on the planet. And his concern it comes from the concern for the future of his children, his grandchildren, and all of humanity. And he's taken a personal interest and responsibility to be a spokesman for global action. Now, I have to say that the other really neat thing, other than being a hero and doing cool stuff for the world, is that Jim started his career working with Ames in the Pioneer Venus mission. So this is an Ames guy made good. So that's really cool. I also want to, we have out here in TV land, as they used to say when we were young, hopefully thousands, maybe tens of thousands of people, as part of the NASA Earth Exchange Training and Climate Modeling under Dr. Raman Namani. Today's colloquium is being streamed worldwide. Students are able not only to listen to the talk, but we're hoping to take questions from our global audience as time permits. Jim, Chief, welcome.
Pete is actually being modest. He is Chief Fulani. I can recognize the fact that science can really be done more effectively and cost effectively with small missions, but to actually do it is a big job. And I'm glad that Ames exists and that Pete has been leading it, because we need to move in that direction. Otherwise, our observations are going to get less and less when they should be getting more and more. Okay, so itinerant farming to White House arrest. I started out okay. I was the fifth of 7 children of a tenant farmer, first son, and we moved from one farm to another, so it was really itinerant farming. You farm somebody else's farm and give them half of the crops, so a sharecropper. So that's a socially useful activity. And then somehow I've ended up getting arrested and thrown in the clink several times. And so the question is, how did I get here, and what would you do if you were in my shoes? I was lucky to grow up at a time shortly after Sputnik, a time when it was easy for to save enough money to go to a state university. And I was particularly lucky because the State University of Iowa, Professor Van Allen was building in his basement instruments and even a satellite. And he had the Geiger counter on the first U.S. Space mission, the first successful one. Discovered the Van Allen belts, of course, and I was far too shy to. I actually avoided taking any courses under Professor Van Allen because I didn't want him to know how ignorant I was. But I got caught up in this research environment in the physics department. When I was a junior took astronomy, and the professor persuaded me and Andy Lasis, who's a colleague. He's not over there. I'm just telling Pushkar. Pushkar will know who I'm talking about. That it persuaded us to take the PhD qualifying exams, and we were the first undergraduates to pass that exam. And so Professor Van Allen noticed me, and I kid Andy because I had a much higher score than him, but we both passed. Anyway, Professor Van Allen told me about this data, new data on Venus, microwave data, which unusually large microwave data, which implied either Venus had an ionosphere or it was unbelievably hot. And of course, it turned out it was very hot, as the Russians soon proved by sending a probe into the atmosphere. And it's hot because it's got a carbon dioxide atmosphere, 90 bar pressure. By that time, I was at GISS in New York, and I proposed an experiment for the Pioneer Venus mission, which got selected. It's the experiment that took this image. We had a little 1.5-inch telescope on Pioneer Venus, which a spin scan could get you an image and it measures the polarization with very high precision, so we can study this veil of clouds which surrounds Venus, which turns out sulfuric acid cloud. But what in the world? Oh, I accidentally pushed the wrong button. Let's see, how do I go back to the beginning? Home? Okay, that was good. So, let me go a little, but it took, the instrument was actually built in Santa Barbara Research Center in California. It took a few years to build it, and in the interim, this was the era of when the ozone problem came up, and I proposed to build a climate model to study the effect of ozone change on climate, and it was selected, and so I started working on that. And one thing we realized then, we wrote a paper about methane and N2O. At that time, it was known that CO2 was increasing a greenhouse gas, and also chlorofluorocarbons. But we pointed out that methane and N2O would actually potentially be a big greenhouse effect. So then I realized this planet was actually more interesting than Venus, because it's changing before our eyes, and there are a lot of people living on this planet, and those changes are likely to affect everybody. So I resigned as the PI on the Pioneer Venus experiment before it got there, and turned it over to another University of Iowa colleague, Larry Travis. But then in about 5 years, we had made some progress and wrote this paper in Science magazine, in which we pointed out from weather station data that the Earth had warmed by about 0.4 of a degree Celsius over the prior century. And that was consistent with what we calculated from the change in atmospheric carbon dioxide. And we concluded that the 1980s were likely to be the warmest decade in the record, in the instrumental record, and that by the end of the century, the warming should be large enough that it would rise above the noise level, the natural variability. And also, we argued that in the 21st century, we would see the erosion of ice sheets and rising sea level, and the creation of drought-prone regions in North America and Asia, and the opening of the fabled Northwest Passage. Well, this got attention, was reported on the front page of the New York Times by Walter Sullivan, and that led to requests to testify to Congress about this topic, global warming, climate change, which by 1988, we finally had our climate model working well enough to do simulations. The 1981 paper was based on one-dimensional calculations. And we had a paper that was accepted for publication in JGR. And so when I testified in 1988, I felt I could make a fairly strong statement about the beginning that it was time to stop waffling so much and say that these gases already were affecting the Earth's climate. And that caused some, along with the huge drought that year, and it was 100 degrees, actually over 100 degrees in Washington on the day I testified. So it got attention. And but I realized that there was some misinterpretation of what I was saying because it was a drought, and actually we know that both extremes of the hydrologic cycle will get more extreme with global warming because the atmosphere holds more water vapor. So when you do get rain at the times and places that you do, can get heavier rains and greater floods. So I wanted to clarify that. So I wanted to testify once more, and I did in 1989. But the scientific message got lost because I also told the New York Times that my testimony had been changed by the White House. And so, that's funny. Well, okay. Then that really got to be a hullabaloo. So then I decided I don't want to be involved in this public stuff anymore, and I'm not a good speaker. I don't like giving public talks or media. So my friend Steve Schneider was quite happy to do interviews. So for 15 years, I would always refer interview requests to either Steve or Michael Oppenheimer, who was then on the East Coast. And so I bailed out of the public aspect of this problem. Oh, and this photo of my first grandchild was, at that time, I showed it in a talk I was giving at Lamont at Columbia University, where the day before there had been an article that called me the grandfather of global warming. And that, of course, was false. People have talked about global warming for 100 years. John Tyndall in the 1850s did the laboratory observations of carbon dioxide absorption, and he is a brilliant interpretations. He inferred that CO2, he suggested that CO2 was the main driver, main mechanism involved in glacial to interglacial climate changes, and he was extremely perceptive. So I wasn't a grandfather of global warming, but I was a grandfather. And I had the opportunity to speak there was a energy and climate task force appointed by President Bush, 6 cabinet members, and the National Security Advisor, Condoleezza Rice, the EPA administrator. And so I had the chance to speak to both their first meeting and their second meeting. And however, there were not policies during that administration that really addressed, in fact, Cheney's plan was to build 1,000 coal-fired power plants. So it had become very clear that the administration wasn't going to address the issue. So I decided I did want to give another talk. This was 15 years after my last testimony, and I got this group agreed to arrange it in Washington, D.C., and it would have press coverage and And I worked for 6 months preparing this talk very carefully and scientific paper to go with it. And then they chickened out and decided, because it was getting close to the election and they thought Bush might win the election, and they didn't want the consequences. So I had to call up my old professor, Ben Allen, and he arranged a distinguished lecture at the University of Iowa where I tried to help get my then 2 grandchildren to help explain how this process, how the greenhouse effect works, the net effect of aerosols, cooling, and gas warming is a forcing of about 2 watts according to Sophie, although Connor could only count 1 watt. And because we're not measuring aerosols, it's not so clear who's more accurate of those. However, that talk didn't get a lot of attention in Iowa City. But the next year I gave the same talk at the AGU meeting in San Francisco, and it did get attention. I also reported that that year, 2005, was the warmest year in the instrumental record. So then there were some couple of calls from the White House to NASA headquarters, and then I had a minder who was telling me when I could speak to the media. And if I got a call from the media, I had to first tell NASA headquarters, and they would decide if someone else should be substituted. And so I let this happen for a few weeks, and they had substituted somebody for me a few times. And then I told the New York Times and managed to get the policy changed. But there are consequences of this, because then several weeks later, in the middle of the night, the first line of the NASA mission statement disappeared, to understand and protect the home planet, which I was informed by Ames, a scientist, Phil Russell. And old age, you can't remember names. It's easier. Anyway, I was, and in addition, the NASA climate research and analysis budget was reduced 30%. And this occurred without Congress being aware of it because it was done in a tricky way by they have to submit some budget updates or something, and so these changes were put in without anybody knowing about it. By soon thereafter, then my son had his first child, Jake, who happens to have a severe peanut allergy, so you have to always have this needle to give him a shot in case he gets a reaction. But I decided, my grandchildren helped me decide that I should start talking more about this topic, and because it didn't seem that anything was going to happen in the U.S., I actually went to other countries thinking that these other countries were different and that the fossil fuel industry didn't rule the capital. I found out that the U.S. is not much different. That other countries' fossil fuel industry has enormous clout, and it's pretty hard to. So what's happened, even though the reality of this issue has become clearer and clearer, the emissions are actually increasing, and even the rate of increase has increased. So the status is that we have this gap between what is understood by the relevant scientific community and what is known by the people who need to know, and that's the public and the policymakers. We actually do have a planetary crisis, but people don't see it. The weather is great. The problem is that the climate system has tremendous inertia because of this 4-kilometer deep ocean, these thick ice sheets. They don't change quickly when you put a 2-watt forcing on them. That's a pretty small forcing, but we know from the Earth's history how sensitive the climate is to such forcings if you give it time to respond. So the system has only partly responded. So some of the warming due to the gases already in the air is in the pipeline. It hasn't occurred yet. And the danger is that we can push the system to points where you pass tipping points where you really can't stop future consequences like ice sheet disintegration, which is particularly driven by the ocean getting warmer and melting the ice shelves the tongues of ice that come out from the ice sheets and go into the ocean once. And then there's also species extermination. That's another thing which can have irreversible effects. And because of the dependencies among species, you can, by driving some of them to extinction by too rapid a climate change, you can potentially get ecosystems to collapse and lose many of them. So here's the global temperature, which has increased now by 0.8 of a degree Celsius over the last century. You hear a lot about this thing that global warming has stopped. That's not really true. 1998 was the El Nino of the century, so it was very warm. But 2005 and 2010 were warmer. And if you look at the 11-year running average to take out, that's the 132-month running mean, to take out the solar cycle, then there's actually, it's still monotonically increasing. And we know that it's going to continue to increase because the planet is out of energy balance. There's more energy coming in than there is energy going out. The greenhouse gases reduce the energy going out. And we can now measure how far the planet is out of balance because most of that energy has to go into the ocean. The heat capacity of the atmosphere is very small. And now, beginning about 10 years ago, different nations of the world distributed more than 3,000 of these Argo floats around the ocean. They dive down to 2-kilometer depth, making measurements, and then come to the surface and radio the data to a satellite. And so we can measure the ocean's temperature and heat content, and what we find is that the heat content of the ocean is increasing. And that's the biggest term in the planet's energy imbalance. There's also ice is melting. That's taking another 1/10 of a watt of energy. So that means the planet is going to keep getting warmer. So you can say with confidence that this decade is going to be warmer than the last one, and the next one will be still warmer. You could, conceivably, you could get something to happen like several Pinatubo's in the same decade, but it's pretty implausible, pretty unlikely. And these measurements, Argo measurements, were made during the deepest solar minimum in the period of accurate measurements, which began in the late 1970s. So even though the sun was dimmer, there was more energy coming in than going out. In fact, this solar, the sun is giving us a negative forcing. This solar cycle is very weak. So you're getting about 1/10 of a watt negative forcing from the sun. But consequences include this melting of ice in the Arctic. And by the way, the Northwest Passage has been open about 3 times this century. So that the end of last melt season, there was only 51% as much sea ice as there was on the average 30 years ago. And that ice was only half as thick. So 3/4 of the volume of the ice is lost at the end of the melt season. And we see on Greenland that the area that has summer melt fluctuates with the weather from year to year, but there's a trend toward increasing areas. And that meltwater will go to a low spot on the ice sheet, burrow a hole in the ice sheet, and then go all the way to the base of the ice sheet where it lubricates the base. And that's one process that speeds up the discharge of giant icebergs to the ocean. Although the melting of ice shelves is probably even more important because that's kind of like taking a cork out of a bottle lying on its side and allows the ice on the mainland to be discharged more rapidly to the ocean. And now we can measure that. One of the Fulani's satellites, this GRACE gravity satellite, one of the, I forget the name of that class of missions, but the smallest that NASA seems to fly, and it works great. Measures the gravitational field so precisely that you can see the changes of the mass of the ice sheet, which gets heavier in the winter as snow piles up and loses mass in the melt season. And overall, both Greenland and Antarctica are losing mass. And this is an update of the Greenland data. It's losing the mass faster and faster. This last summer was the biggest mass loss from Greenland, about 500 cubic kilometers of ice integrated over the winter and summer. The net loss was about 500 kilometers. So it's a question of how fast that is going to accelerate. If we stay on business as usual, in my opinion, we will get ice sheets collapsing pretty rapidly. West Antarctica is also losing mass. That, as I say, is a practically irreversible effect. If ice sheets disintegrate, then they took them tens of thousands of years to build up from snowfall. So that's irreversible on timescales that humans care about. The other thing, the species extermination. I use the monarch butterfly as a good example. I don't scare my grandchildren about global warming by telling them there's a problem. I think that's our problem. It's not the children's problem. But it is useful to introduce them to nature. And monarch butterfly is a good example. Monarch butterflies are under stress, have been under stress for the last decade or two because of Roundup, the pesticide that farmers use to kill weeds, which also kills milkweeds, which is the only thing that the monarch larvae can eat. Monarchs are a spectacular example of life on our planet. They migrate from Canada to Mexico and back, which takes like 4 generations. Female has to lay eggs on a milkweed plant, and then you go through this caterpillar to chrysalis stage. It's incredible. And if the monarch gets blown off, and they migrate to this small area, a small piece of on a mountain, some evergreen trees in an area, and they find their way back there, which is an interesting problem. But even if they're blown off course 1,000 kilometers, they find the right spot. But this 2011 summer was, but I noticed that we only see like 1 monarch at a time. We used to be, my wife and I would see a dozen monarchs in our little property in Pennsylvania. Now we're saying we only can see like 1 or 2 or sometimes none. But this summer, there was just this one butterfly flitting around. It's this broken wing. This is a female with a broken wing. And I ran off to Washington because there was a hurricane coming. I had to give a talk. I wanted to get there before the storm hit. That storm wasn't a hurricane when it got to our farm, but it dumped 8 inches of rain and high winds. So I thought, wow, this monarch will never survive, let alone her caterpillars, which had started to, because she was the only one there for 3 weeks. So I knew it was this butterfly that had started these caterpillars, which you can see. But I came back, and here that same butterfly was flitting around the yard, and caterpillars were still there. They disappeared in the bushes. And then sometime later, 2 butterflies were appearing. They're still hanging there, trying to dry their wings after coming out of the chrysalis. One of them was a male, which you see here, and then one is this female. So that butterfly produced about 25. So she certainly did her share for sending them on down toward Mexico. But we were wondering, are they going to get to Mexico? Because that was the year of this huge drought. in Texas. Well, it turned out there are people there who count the butterflies because of the problems with that. It turned out there was about a 30% reduction in the number that made it. This is a branch on one of those evergreen trees where the monarchs arrive. I'd written an article about the monarch, and a Mexican scientist sent me some photos. That's his son looking at those butterflies. And what they see is the trees are doing very poorly because of the climate change. And so he's trying to convince the Mexican government to plant some trees higher up the mountain. It's getting too warm, and with the drought. So anyway, but he says that by 2090, if we stay on business as usual, the mountain won't be high enough. You have to find a different place to grow this particular tree. Now, last winter, the number that made it to Mexico was reduced by, I think, 55%. So now the number of monarchs is only 7%, as many as it was 3 decades ago. So they may end up getting in a threatened species. But there are lots of other species. You know, the coral reefs are the rainforest of the ocean, with about 1 million species associated with them. And the coral reefs are really under stress because of ocean acidification, as the ocean takes up CO2, and because of the warming ocean, which causes bleaching of the coral and can kill the coral. And so there is an issue about potential climate effects on species, which they call reduction of biological diversity, which is a nice way of saying extermination of species. But in addition, there are things that are happening now which people, if they're observant, should be able to notice. The distribution of temperature anomalies for the summer temperature anomalies is shifting because of the warming. If we calculate the anomalies relative to the climate of the last century, then we see that the recent decades have been noticeably warmer. So the extreme events, more than 3 standard deviations relative to the climate of last century, now occur about 10% of the time rather than less than 1% of the time. And those extreme hot summers will occur where you happen to have high pressure that summer, so you get stronger droughts there. And so it moves around the places where you have this unusual temperatures, but it's happening noticeably more frequently. And those extreme conditions do contribute to more extreme fires, forest fires, which burn hotter and are therefore more damaging. And in the United States, Mediterranean region, Australia, you have a noticeable increase in those fires. There's also a lot of places where 100-year floods are occurring more often than once a century. And storms that are driven by latent heat, that means thunderstorms, tornadoes, and tropical storms, all have the potential to be stronger because the fuel for them is water vapor, the latent energy in water vapor. And this particular storm, which is a Category 1 hurricane, Sandy, which was kept as a Category 1 storm because it was 2 or 3 degrees, the ocean water was 2 or 3 degrees above normal along the east coast of the U.S. So it made it all the way up to New York City, and then combined with a frontal storm so that it moved into the continent and caused a lot of damage on the East Coast, including my farm, by the way. Still, the politicians really didn't notice it until Mayor Bloomberg sort of forced it on them. seem to prefer not to pay attention to this issue, even though the science has become crystal clear. What is crystal clear, what they should be talking about, is the fact that we can't burn all the fossil fuels. We've burned so far the purple parts of the oil, gas, and coal, the conventional fuels. The problem would be solvable if we would phase out coal emissions, which are almost entirely at power plants, and if we would leave the unconventional fossil fuels in the ground, because the amount of conventional oil and gas is finite, and of course if you keep going after it in the deepest ocean, in the most Arctic and Antarctic and things, you could cause a problem. But if we would not do that, the problem would be solvable. But it would require phasing out coal and no unconventional fossil fuels. That's not happening. On the contrary, we're doing exactly the opposite. We're allowing and encouraging and subsidizing fossil fuel companies to go after every fossil fuel they can find, including the unconventional ones. And that's so now the boy with the peanut allergy thinks that he can protect his baby sister. So this is of course, we, on the contrary, are very much in danger of leaving them a situation that's out of their control. And our parents did not know that they were causing a problem by burning fossil fuels, but we can only pretend that we don't know. So what can you do about it? Well, Sophie is now, she's 12 years old in this photo, but so she is writing a letter to President Obama. And she was quite sure I was going to like that letter because, among other things, she said, "Why don't you listen to my grandfather?" So after reading that, we were celebrating her good letter. So this, this is a strange situation because every culture pays attention to the future generations. At least that's the way it seems it always has been. But governments seem to think they can just set emissions at whatever level they choose. So one thing you can do about it is try to take the government to court. And that's one advantage that I have now. I'm now allowed to testify against the government since I'm not an employee any longer. And there's this, there are legal actions that have been filed based on a paper that Pushkar and I and some other people have written, other scientists have written, in which we specify how fast you would need to reduce emissions if you want to balance the planet's, if you want to restore energy balance. And that's what you need to do if you want to stop climate change. And that would require reducing emissions about 6% a year. And if you did that, and if you did 100 gigatons of storage of carbon in reforestation and better agricultural practices, you could get back to 350 ppm and get a balanced budget by the end of the century. But it remains to be seen whether the courts can help. Courts don't often get far out in front of public opinion. They did help in the case of civil rights. They told the government, you give us your plan. That's what we're asking in these legal cases. Give us your plan for reducing emissions. And the courts asked the government to give them a plan for desegregation, for example, and they could call the government back into court if they didn't live up to their plan. But the basic problem is that fossil fuels seem to be the cheapest energy to the consumer. But that's because they're subsidized and because they don't pay their cost to society. Just the human health effects of air and water pollution alone would put a significant increase in the price of fossil fuels. But who pays that? You pay. If your child gets asthma, you pay the bill, not the fossil fuel company. And the climate changes. If sometimes the government will come to the rescue after a climate disaster, but that's the taxpayer coming to the rescue, not the fossil fuel companies. So the main thing that's needed is a rising price on carbon emissions. Other things are required, but that's the fundamental underlying requirement, or we cannot solve the problem. Because even if somebody decides, oh, we're going to reduce our emissions by such and such, it doesn't help, because that reduces the demand for the fuel, makes it cheaper, and somebody else, someplace else will burn it anyway. And the carbon will stay in the system for millennia. So burning it a little bit slower does not help. You have to leave the fossil fuels in the ground or capture the carbon as you burn it and put it back in the ground. Otherwise, you can't solve the problem. So what I say you should do is put a fee on carbon, collect it from the small number of domestic sources, the domestic mines and the ports of entry. And very simple, almost zero cost to do that. And then you distribute the money to the legal residents of the country, an equal amount to each legal resident. Then 60% of the people, the people who do better than average in limiting their carbon footprint would get more in their dividend than they pay in increased costs. But they would need to pay attention to their carbon footprint, because that fee is going to keep going up, and some people are going to reduce their emissions. With the present distribution of energy uses, 60% of the people would get more in the dividend than they pay in increased costs. If you own 2 houses and fly around the world, then you'll pay more, but you can afford to do it. It's not that big a tax for a rich person. And this is the only way that you can, in my opinion, that you can get an international agreement. All we really need is China and the United States to say, let's have a carbon fee, a rising carbon fee. And frankly, China is ready to do that. They know that, first of all, they're run by engineers. The country is run by engineers, and they know the climate issue is real. They have 300 million people living near sea level. They have air and water pollution from fossil fuels that they would like to eliminate. So if you had an agreement between the U.S. and China, then they can say, we're going to put a border duty on products from countries that do not have an equivalent carbon fee. That would be an enormous incentive for those other countries to have their own fee so they could collect the money rather than have us collect it. And it's a conservative plan because it lets the marketplace make the decision. Instead of government trying to say, oh, we can solve this by getting everybody to put solar panels on their house, let the market decide how the role of energy efficiency and renewables and nuclear power and carbon capture and storage. There are many possibilities for reducing carbon footprint, and the government never makes the right choices. Here's the current situation in the United States. Some people are counting on the renewables. There's quite a bit of renewable energy. It's the blue, that's the hydropower. All the other renewables are still almost invisible on the chart. They have a role to play. My barn is covered by solar panels. It generates twice as much energy as we use. But we shouldn't pretend that that's the whole answer. And it is possible to decrease emissions rapidly. Here are a couple of examples of success stories. France increased its electricity from 8% to 70% no carbon electricity by nuclear power a few decades ago. Germany has decided to is doing everybody a favor by just seeing how much can you do with renewables. So they're investing an enormous amount of energy in trying to go to renewables, and they have succeeded in going from 4% to 19% in 2011, and I'm sure it's a couple of percent more than that last year, but the data is not available yet. So it's possible to make rapid changes. Is that my last chart? I guess that's my last chart. Okay, so I'm ready for questions. By the way, I do recommend this Citizens Climate Lobby. They exist now in almost every state, and they are advocating, they're writing op-eds and visiting Congress people and trying to persuade the public and officials that we need to have a carbon fee, and the money should go to the public, not to the government, and to make the government bigger.
Hi, thank you for coming. This whole press denier blitz about the pause in warming has got those of us who are blogging to counter it, trying to explain about things like ocean heat and the model means versus model runs and the spread. Okay, the model means stuff, maybe that's too hard for a press release, but it's frustrating when climate scientists talk about there's been a pause in global warming without tossing in, oh yeah, if you look at the oceans and the total heat content. Is there some reason that other than, well, we've got more data, longer data on the surface atmosphere than we do on everything else? Why do they keep saying that instead of just saying, well, no, if you look at the whole system, the heat content, that's not slowed down?
Well, you don't even have to do that. Just look at the surface temperature data. The warmest year in the record is 2010. And as I showed, the decadal mean temperature is still warming. The rate of warming may be slightly less in the last decade, but that's not a surprise. You know, it's not supposed to be the same every decade. It is going to be warmer each decade, and I show maps of the decadal mean temperature, and each decade has been warmer than the one before. So it's a case of this is a very common, this has happened many times already. It's with different issues. Every time the deniers find a piece of data, and you're going to get fluctuations. And every time they find anything that they can say is different, or they'll pretend that this changes the story. Well, this has no effect on the status of the scientific story. You know, but they're successful in confusing the public with this tactic. It's well described in the book Merchants of Doubt. You know, that it's a tactic which politicians can easily avoid the consequences of that. You know, Abraham Lincoln established the National Academy of Sciences to advise the government on technical issues. All the president has to do is ask the National Academy of Sciences, what's the status? And if he wanted to have a more substantial response, he could get them to provide the basis for that. But presently, it's difficult. That's just one of the examples. But so the public, but nevertheless, the public in the United States now agrees climate is changing, and there's even consensus in the public that humans are at least partly responsible for that. So we could we could take logical steps, and the analogy is made to insurance. Even if you're not certain exactly what's going to happen in the next few decades, and you still should be taking actions to avoid handing our children a situation which is going to be very difficult for them to deal with.
Currently, CO2 is running about almost 400 parts per million, and we're experiencing right now a melting of Greenland and Antarctica, and apparently from your charts, they seem to be melting even faster. I'm curious, are there any studies that would forecast how much faster, what the rate of increase is going to be as we go through the next doubling of CO2? I guess what I'm looking for is unknown exponential increases in sea level rise.
Yeah. Unfortunately, we have no realistic ice sheet models. The ice sheet models that were developed were principally tuned to work for the natural variations of ice sheet size, which occurred. Ice sheets have come and gone many times, but those changes in the natural world were driven by the Earth orbital changes and the Milankovitch changes. The fastest time constant there is about 10,000 years. I mean, the cycle is 20,000 years. 20,000, 100,000, 40,000 are the time scales, time constants. So that's sort of the time scale that ice sheets changed on, although when they did collapse, some of them, it did change a lot in just a few thousand years. During this last transition from an ice age to the current interglacial, at one meltwater pulse 1A, sea level went up about 20 meters in 500 years, so as much as 4 or 5 meters a century. Now, we know that during the last interglacial period, it was about 2 degrees warmer than the current interglacial prior to the human-made warming, so about 1 degree warmer than the current temperature. And at that time, sea level reached heights of at least 6 meters above the current level. So we should anticipate that. But what you're asking is how fast is it going to happen? And actually, if we do business as usual, we will put enough CO2 in the atmosphere to go back to the ice-free state, which is 70 meters higher, 250 feet higher. But how fast? I think that it will be a lot faster than what IPCC has been talking about, because it's a nonlinear process, though, and therefore inherently very difficult to say when something will collapse. But if you took that short record that we had, it looks like an exponential. And I would argue that with a nonlinear process, an exponential is more likely than a linear change, until the change gets to be big enough to bring in a negative feedback, which will slow the process. And the negative feedback that I anticipate is that once you start putting enough ice in the ocean to cool the ocean, you can get to a point, in fact, we've modeled this and we're writing a paper about it, where by the time you get to between 0.5 meter and 1 meter sea level rise, which we put in the exponential thing with the 10-year time constant. So this century, we get to a point where we get 5 meter sea level rise. But before we get there, if I just get to 0.5 meter to 1 meter, it starts to cool off in the North Atlantic and goes several degrees below the current temperature in the North Atlantic. So Europe actually gets cold. This is what Wally Broecker had talked about 15 or 20 years ago, and then he got beaten into submission by the scientific community who said, no, that won't, our GCMs show that doesn't happen. but their GCMs had ice sheets that were were stable, you know. And when we put in this ice melt, we get the phenomena he was talking about, a strong cooling in the North Atlantic while the tropics are warming. So you increase temperature gradient and therefore very powerful storms. And I started to make these calculations before I wrote my book. And that's where the title came from, Storms of My Grandchildren, because that's where we are headed if we don't slow down our emissions.
Hi. Yes. So you're going to have to excuse me because I'm not real good with my different categories of fuel emissions, but I've been reading a lot in the newspaper that there's been these large discoveries of natural gas in the United States, and that this could change, you know, how we use natural gas. Can you comment for me? Like, does that make this problem worse? Does it make it better? How does this affect it?
It depends on whether we're clever or whether we're stupid. If the statement is made that gas should be the transition fuel to a clean energy future, stop using coal, replace it with gas, and then move to a non-carbon fuel eventually. Well, what we're doing, so that would actually make sense because gas is only a bit more than half as much carbon per unit energy as coal. So if that's what we were using the gas for, and planning, if we were taking the actions that would lead us to a clean energy future, then it would actually make sense. What we're doing, however, is going after every fossil fuel we can find. We're encouraging and even subsidizing fossil fuel companies to go after every fossil fuel they can find. So there's no intention of phasing out the gas. And the problem is the bar is broken up there because there's so much potential gas. We can't burn that unless we capture the CO2 and put it back in the ground, and we're not doing that. So that has not sunk in. Policymakers do not hear what we're saying, and yet there's zero disagreement. You know, I was at a meeting recently of about 20 of the top scientists because Wally Broker's got enough clout to, if he calls up and says, come to a meeting, then the scientists came to the meeting. And the interesting thing about the meeting, it was a meeting about carbon capture. They were trying to get scientists to recommend that that the government had better be looking at carbon capture. And it was just taken for granted by all these scientists who know what the story is, that it's probably too late to stabilize climate other than via geoengineering. And so they're, in effect, thinking of a geoengineering solution, one which is to capture the carbon out of the air and put it back in the ground. So it's curious to me because it means that we went from a status of where it was too early, because I kept being accused of jumping the gun on this issue, but we went from a status of it being too early to, oh, it's too late, without going through the phase of doing something sensible.
Hi, up here. Hi, my question is sort of a philosophical one. You spoke briefly of a knowledge gap between what the public knows and what climate scientists and other scientists know. And my question is, whose responsibility is it to bridge this gap? Is it climate scientists? Is it educators? Is it the media? You know, how can we communicate? How can we, as people who understand climate science, communicate that in a way that is actually meaningful to the public and get them behind, your fee and dividend idea and all of that. Do you have any suggestions for that?
Yeah. The problem is manifold. There are different things. One thing, several years ago, I wrote a letter. ExxonMobil was found to be paying for people who were changing textbooks to indicate that the climate problem was really not understood, whether humans were affecting climate or not. It was still very uncertain. And I made the comment that I considered that a crime against humanity and nature, to be doing something when they know that what they're saying is baloney. But they're willing to do that just so they can keep their profits up. But the media is part of the problem, partly because they like to always present this side and that side so you can have an interesting story. Even when the evidence is very heavy on one side, they make them appear equal. But that, in fact, the media is in some way heavily responsible, but just because with our system you're allowed to buy time. And we don't have a system where television programs are subsidized by the government. They're paid for by advertisers. And there's no one who can compete. People who are concerned about the environment cannot compete with the fossil fuel industry. So you're hammered every day with the story that about clean coal and even clean tar sands, so it's difficult to get the public well informed. And we scientists are not very helpful because we're not very good communicators. And to some extent, that's, understandable. So the solution, there is progress. Bill McKibben is getting when we would go to these demonstrations, it'd be a handful of people, and usually be the same people. But at least he's managed to get young people involved, which is important because they're the ones who are going to have the consequences. And the numbers are increasing, but they're still small compared to what is needed. If you think of civil rights, it took quite a while before you got people in the street and enough to provide the pressure on the government and the courage for the courts to do what was right. And unfortunately, in this case, it's particularly difficult just because of the time constant of the physical system and the fact that you don't see the response immediately. So that makes it very dangerous. I still think we can do it. It needs to involve technological solutions, but those would be spurred by an increasing carbon price, and they're just not likely to happen as long as we allow fossil fuels to be so cheap that people are just going to keep burning them.
Jim, I have the next one over here, Dave Morrison here. I just want to thank you for all you've done on behalf of myself and the many scientists who work at Ames. An example of a scientist who sticks to the science, who serves the American people, and even on occasion speaks truth to power. And thank you.
Okay, so Jim has agreed to stay here as long as necessary to answer all your questions, but anybody who would like to leave is free to leave. And we're going to take one more question from the audience, and then we're going to go to online for questions. Okay? Are you online? Okay, well, let's go online then.
One of the questions we had is about the position of WTO on the fee and dividend.
Yeah, okay. The question is, what is the position of the World Trade Organization, WTO, on fee and dividend? The answer that I've received to that question is that they would allow border duties of the sort that I mentioned, as long as they're equivalent to the carbon fee. And the reality of WTO is that if the United States and China said they were doing this, they would go along with it. And everybody, and I would expect Europe, for example, to join in promptly. So I do not think that there's any regulation, that international regulation that would stop a desire to have a multilateral agreement on carbon fee with border duties on those who don't have the carbon fee.
There's another one actually concerned about how, is there, for green energy sources, is there actually any negative effect on them too? I mean, for the climate or Earth?
Is there a negative effect of green energies?
Right, on climate or Earth?
Well, you know, virtually any energy source has costs associated with it. Environmental costs, you know, as you know, hydropower raises objections, the effect of dams on fish and other wildlife. Windmills raise objections both for the effect on the aesthetics and on birds. This production of solar panels, if you look, because you have to get these rare earths, and because, so if you go to the facilities in China where they're made, there's a lot of regional pollution associated with them. So it's a matter of balancing those. So one merit of the rising carbon fee is that it will, first of all, put a very high value on conservation and energy efficiency, which, given our, in many cases, overconsumption, you know, we're producing and buying more things than we need, and even people recognize that. But so to have some forces that kind of tend to mitigate that is one of the merits of making fossil fuels pay their cost to society. But the others, you also ask whether it has climate, a negative, or an impact on climate. I guess, well, people have looked at, what if we put up enough windmills to get all of our energy? That can possibly affect regional winds and have some regional climate effect. I suppose, but I think those are relative to what we're trying to cure. It's probably a relatively minor thing.
Are you up for one more question?
Sure,
All
as
right.
many as you like.
Right here.
If we're not ready to retire yet, what would you suggest we can do at Ames or NASA to get our country on track?
Yeah, you shouldn't have to retire I mean, of course, as I mentioned with regard to Pete Warden, Ames is pretty good at technological things, and we have deficiencies in our knowledge. You know, when you talk about this relative reduction in warming in the last decade, part of that is may well be related to atmospheric aerosols. China restarted burning coal so much more rapidly that there certainly was an increase in atmospheric aerosol amount. But we don't know it. We don't know the properties of the aerosols allowing us to compute the climate effect. We know there is a partial balancing of the warming effect of greenhouse gases by human-made aerosols, and we really should quantify that. We had actually proposed to have a small satellite mission in collaboration with Ames, and when that got declined by Goddard Space Flight Center, it was one of the reasons that encouraged me to say it's probably time to do something else if we can't even get support for such a fundamental measurement. But those the NASA technology can contribute certainly to measurements and very possibly to things that will be useful in the energy sector.
Well, I'd like to end this discussion period with another round of applause for our speaker for a great talk. And let me remind you that there are refreshments in the lobby of Building 200, and Jim's going to stick around, I think, for a little while, so you may get an opportunity to ask a question.
Jim, one quick question for you. This China thing, you know, there's so much fatalism around. I think that's a great story.